So what we have today is we're doing sine and cosine and how it relates to the unit circle. We're going to start off very slow. We're going to show you how this relates to specific right triangles. Okay, so here we go. All right, the first we're going to look at is just a right triangle in general and explain the different sides of a right triangle. But to do that, we need to put down what's called a reference angle. A reference angle is whatever angle you are looking at in your right triangle. We are going to put our reference angle in the lower right-hand corner. Okay, and there it is. We're going to call it theta. Now, theta is just a Greek letter we use to signify angles in a triangle. It's like a variable like x or y. We just use Greek letters for angles. Okay, so the first side we want to designate is this one on the left. Okay, it's this dark blue one. And it is opposite of our reference angle, so we call it the opposite side. Okay, next we're going to look at the red one on the bottom. This is next to our reference angle, and we call it the adjacent side because it's next to. And lastly, we have the green line, and this is across from our right angle, which is in the bottom left-hand corner there, signified by the little box. And that is always going to be your hypotenuse. Okay. Now, your adjacent on opposite sides can switch depending on where the reference angle is. If the reference angle was on the top left-hand corner, then the adjacent would become the opposite, and the opposite would become the adjacent because now the reference angle has moved. But for right now, let's just focus on these three side length names: opposite, adjacent, and hypotenuse. Okay, and the reason they're important is because we're looking at right triangle trig stuff. We have this mnemonic device to help us remember. It's called Sohcahtoa. What it means is that for so you have the sine of theta. This is a sine is a trig function, is the opposite side divided by the hypotenuse side. Okay, so it's a ratio, it's a fraction. It's going to have the opposite side over the hypotenuse side. This is going to be important for later. All right, for cosine, for ka there in the middle, we have cosine is equal to the adjacent side divided by the hypotenuse side. And lastly, we have toa, which is the tangent, which is going to be the opposite side over the adjacent side. Now, for what we're doing today, we're mainly concerned with sine and cosine. I don't really care too much about the tangent function. Okay, so why is this important? Okay, so let's look at two specific triangles that exist. The first one to look at is the 30, 60, 90 triangle. Now, you should have seen this some in Math 2. And the sides of this triangle have a specific relationship that makes them special. Okay, so you have x, x root 3, and 2x being the sides of your 30, 60, 90 triangle. Now, what we're going to look at is the sine and cosine of 30 and 60 degrees and see what happens when we see those sides and what numbers they give us. So first of all, we're starting with the 30 degrees. So 30 degrees, if you remember Sohcahtoa, 30 degrees, looking at the side for 30 degrees, we're looking for the opposite side and the hypotenuse side. So that's going to be the x and the 2x sides. Well, now what we're going to do is we want to reduce this fraction of x divided by 2x. What happens is the x's will cancel out and you'll be left with 1/2. Okay. Next, we're looking at the cosine of 30. And the cosine of 30 is going to be the adjacent side over the hypotenuse side. Your adjacent side from 30 is x root 3, and your hypotenuse is again 2x. And again, we want to reduce this fraction by canceling out the x's. You're left with root 3 over 2. Okay. All right. Next, we're looking at the sine of 60 and the cosine of 60. Now, when we're looking at the 60-degree angle, that means our sides are going to change, like I mentioned at the beginning, where now our opposite side and our adjacent sides will flip. The hypotenuse will always be across from the right angle, but the adjacent and the opposite sides will flip their positions. Okay. So for 60, we're looking for the sine, doing the opposite. In this case, the opposite is the x times root 3, and the hypotenuse will be 2x. Again, we reduce this fraction, we're going to get root 3 over 2. And then the cosine of 60, do the adjacent over the hypotenuse, which gives us x over 2x. And if we reduce that fraction, we're going to get 1/2. You'll notice there's a relationship between sine of 30 and cosine of 60. and then cosine of 30 and sine of 60. Okay, they're the same numbers. Okay. Now these numbers are going to be very important as we move on through this unit, so pay attention to those. Okay, there's one more triangle that's important to us, and that is the 45, 45, 90 triangle, which we see here. Okay, so if we're looking at a 45, 45, 90 triangle, it doesn't make a difference which 40 you look at, because the sides that are opposite and adjacent for a 45, 45, 90 triangle are both going to be x. Okay, this is another example of a triangle from Math 2 that you guys should have done. Okay, and looked at the special relationships between the sides of a 45, 45, 90 triangle. Okay, so if we do the sine of 45, the sine is going to be the opposite over the hypotenuse, which is going to be x over x root 2. Right? If we reduce this fraction, we get 1 over the square root of 2. Now, in math, we don't really like to put square roots of numbers on the denominators of our fractions. So we're going to multiply that to the top. We're going to end up with root 2 over 2. All right, for cosine, we're going to do the same thing. So it's adjacent over hypotenuse, which is again going to be x over x root 2. We reduce the fraction, get 1 over root 2, and again, we don't like square roots in the bottom of our fractions, so we multiply to the top, and we get root 2 over 2. So I've included this nice little chart over here to help us out. So for the sine of a functions between 30, 45, and 60, you're going to have 1/2 for 30, root 2 over 2 for 45, and root 3 over 2 for 60. And for cosine, you're going to have root 3 over 2 for 30, you're going to have root 2 over 2 for 45, you're going to have 1/2 for 60. Okay, so this is going to be important numbers as we move forward in this unit to recognize and understand what they're going to do for us and what's called the unit circle. That's going to be what's going to happen tomorrow. All right, so thanks for joining us, and we will see you tomorrow.